So the question is, a rod AB of length 15 cm rests in between two coordinate axes in such a way that the end point A lies on the x-axis and the end point B lies on the y-axis. So we have a rod and let's name it AB. AB is a rod and which is 15 cm long. 15 cm long, and this is lying in between two coordinate axes. So let this be y-axis and let this be x-axis. Okay, so y-axis and x-axis, and this rod AB is lying in between these axes in such a way that A lies on the x-axis. The end point A, this end point A lies on the x-axis and the end point B lies on the y-axis always. Whatever the situation may be, if it is lying in the first quadrant, A will also always touch the x-axis. Either if it's lying in the second quadrant, then also A will lie on the x-axis and B will lie on the y-axis. If it is in the third quadrant, the same will happen. A is on the x-axis and B is on the y-axis. So the question is saying that A lies on the x-axis and B lies on the y-axis. This condition should be maintained throughout the question. Okay, so where were we? The length of the rod is 15 centimeter and we have a point P. Let the point P be here and let the coordinate of this can be written in the form of x and y. So P is a point xy such that AP is 6 centimeter. The length between the point A and P is 6 centimeter. As the rod is 15 centimeter long, so PB will be 9 centimeter. So the question is saying, if the rod of 15 centimeter has a point P on it which is 6 centimeter far from point A, which point A is lying on the x-axis, then if this rod is kept in between the axes, the locus of that P will form an ellipse. Okay, so this might be seem confusing. So let's see it in another way. Okay, look at here. There is y-axis and x-axis. Okay, and we have a point P on a line AB. Suppose it's a rod AB. We have not marked it yet. So note one thing, that this question is a particular question where the length of the rod is 15 centimeter. If we have to understand this question, we should go in some general way. Suppose whatever the length of that rod will be, but it is lying in between the axes and a point P is somewhere on that rod, but that P is not changing its position on the rod. Okay, so P is a point on the rod and whatever its length will be from A, that means x-axis, it will always form an ellipse. Let's see how. If we'll change the position of the rod, look at here, we have changed the position of the rod, so the position of P will also change. Okay, so the traces of P, or I should say the locus of P, will form an ellipse. First we have the rod in the first quadrant, now the rod has gone into the second quadrant, but the condition is maintained that A should also always lie on the x-axis. Okay, look at this, the point touching the x-axis will never leave it and the point touching the y-axis will also never leave it. So let's play it one more time and see this. Okay, you can see that the locus of P is forming an ellipse. Okay, this is exactly what the question is saying, but in a particular way, that we have a length of the rod 15 centimeter and the point P is 6 centimeter apart from point A. So let's go to the question now. Okay, let's go to the question. We should make another graph so that we can solve it more easily. Suppose this is y-axis and this is x-axis. No, it is not straight enough. We'll try one more time. Oof. This line is giving me a hard time. Okay, this is good enough. Okay, so this is y-axis and this is x-axis. Now a rod AB, so this is our rod AB, where A is lying on the x-axis and B is lying on the y-axis, and we have a point P. Suppose this is the point P, this is the point P, and its coordinate are x and y. So the point we should note here, that if this is P, this length will be y and this length will be x. We should draw a perpendicular from point P on both the axes. We will get the distance x and the distance y, because it is the coordinate x, P, x and y. So this length will be x and this length will be y, and this is perpendicular, so this line and this line will be parallel. This is obvious. I don't have to tell you so much about it, that the length will be y and x respectively. Okay, so as AP is 6 centimeter, AP is 6 centimeter, and PB will be 9 centimeter, because the whole rod is 15 centimeter, so PB will be 9 centimeter. Okay, we have to find a relationship between x and y. We have to find the locus of the point P, so we must have a relationship that will define the point P all over the Cartesian plane. Okay, so what will be P? uh, uh, First talk about the x-axis, sorry, x coordinate of the P. Okay, okay, look one thing here. If our rod has a new position, let this be a first position, the rod will change its position with time. We have to find the locus of P, so all possible position of the rod should be considered. Suppose this is the new position of the rod and here is the point P. Now it is somewhat higher than the earlier position with respect to y-axis. Okay, so when we change the position of the rod, the inclination is also changing. Here the inclination must be, let us suppose it is theta, and suppose here it is phi. So for every possible situation, the only thing is changing is theta. So x is varying on theta and y is also varying on theta. Okay, if theta is some other angle, then the coordinate will be something different. Okay, so let's get back to our main problem. We will not consider all the positions, we'll only see for a particular general, we'll take it a general way. Okay, so what will be the x? Suppose this is theta, so this angle will also be theta, as it is parallel. You can understand it, both the angle will be theta. Okay, so if this is P and let it be C and let it be B, the point where P is falling perpendicular on y-axis, let it be point C, and the perpendicular from P to y x-axis will be the point D. Okay, so in triangle P, B P B P C, let it be, or I should write BCP. Okay, let in the triangle BCP, cos theta will be x by 9. This implies x is equals to 9 cos theta. Okay, and now in the triangle PDA, in triangle PDA, sin theta will be y by 6, because this is theta, so this will be perpendicular and this will be hypotenuse, so sin theta will be y by 6. Now y should be 6 sin theta. So the point pxy is now known in the terms of theta, and that is 9 cos theta and 6 sin theta. Only thing is left to find a relationship between x and y. These are the coordinate for all possible positions of the rod AB in between the axes. Okay, so x is equals to 9 cos theta. How can we relate this x and y? Y is 6 sin theta. uh, we have a relationship between cos and sine that is in square form. So let it be equation first and let it be equation second. Squaring equation first. Squaring equation first. So what will we get? X square is equals to 9 square cos square theta. Okay. Now, if we'll see it carefully, cos square theta can be written as 1 minus sine square theta, and sine theta here from 2 we can write sine theta. Let's see what is equation 2. Y is equals to 6 sine theta, so sine theta will be y by 6. Okay, let it be equation third and let it be equation fourth and make it equation third. Now putting the value of sine theta from equation 4 into the equation third, will get x square is equals to 9 square 1 minus y by 6 raised to the power 2. Okay, and with some rearrangement we'll get this equation. Okay, this is the equation we are getting finally. And now look at it. What does this equation means? If you will recall, this is an equation for an ellipse. Okay, this is the standard equation for an ellipse where uh, x intercept is 9 and y intercept is 6. So the p can be expressed as x square by 9 x square by 9 square plus y square by 6 square is equals to 1. So the locus of p is an ellipse. It must be an ellipse, otherwise the equation should be something different. If it is an equation of ellipse, so it is clear that the locus of p is an ellipse. Okay, thank you for your time. Good luck.